Okay, in this lecture we're going to talk about multiplying and dividing rational expressions. And we do this exactly the same way as we do it with regular fractions. So for example, if I had 2/5 times by, say, 3/4, then I'd just multiply it through and I'd get 2 3s are 6 over 20, which of course is 2 by 3 over 2 by 10, which of course leaves us as 3/10 in lowest form. If we had 2/5 divide by 3/4, then what we'd do is have 2/5 divide by 3/4, which comes out to be 2/5 times by 4 over 3, because we inverted and multiply, and this would give us 8/15. So we do exactly the same thing for rational expressions, and so the rule is, right, for a over b and c over d, of course b and d are not equal to 0, then we have a over b times c over d is simply a c over bd, and if I have a over b divided by c over d, then we have a over b times d over c, which gives us a d over bc, and we have a further restriction that c can't be equal to 0. So let's look at some examples of doing this. Alright, so let's suppose that we want to do 6x to the 6 over 14 by 21 over 9x squared, say. So this would become, alright, we multiply these all through. Now, to keep track of what numbers we are able to cancel out in the top and the bottom, we break up the numbers into their factors. For example, 6 would be 2 by 3. Alright, 21, of course, would be 3 by 7. And x to the 6, alright, since we have an x squared in the bottom, I'm going to use that x to the 4 by x squared. 4 plus 2 is 6. Over 14 is 2 by 7. By 9, which is 3 by 3. And we have an x squared. Alright, so let's see what we can get this in the lowest terms. Well, 2's will cancel here. 3's will cancel here. Alright, and 3's will cancel here. 7's will cancel here. And x squareds will cancel here, and I'll be left with x to the 4. Alright, so let's do, that's part A. So let's look at part B. Let's suppose that we have now 2y take 1 over y plus 4 times by 4y squared plus 3y subtract 10 all over 2y squared plus 3y take 2. Now in this case here we have quadratics in the top and bottom here, so we're going to need to factor those first using our techniques. So let's keep the first ones the same. And we're going to need to now factor this one here. So 4 times negative 10 is negative 40. Right, and we want factors of negative 40 that add up to 3. Well, that'll be 8 and negative 3, of course. Sorry, 5. 8 and negative 5. So that means that we can write this as 4y squared plus 8y subtract 5y subtract 10. Right, now we need down here 2 by negative 2 is negative 4, which add up to 3. Well, that'll simply be 2y, okay, and a y, and of course we're going to need 4y, so let's do that one, and we subtract 1. Alright, so this now becomes 2y subtract 1 over y plus 4 times by 4y, take out a factor of here, so we're going to have a y plus 2, take out a negative 5 over y plus 2, and this is all over 2y take 1 by y plus 2. So this now becomes y plus 2, okay, in the top part here, and we have a 4y take 5. And of course we have this guy here. Now we can put that at the end. It's okay. Like so. Let's put that there. And over here we're going to have a 2y take 1 by a y plus 2. And let's not forget this guy here, which is y plus 4. Alright, so what can we get rid of here? Well, y plus 2 is in the top and the bottom. 2y take 1 is in the top and the bottom. And so our result will be 4y take 5 over y plus 4. Alright, let's do another one. Let's suppose we have 5 p squared minus 16p plus 3 all over p squared plus p minus 12, and then we're going to divide by 30p squared minus 6p all over 2p cubed plus 8p squared. Alright, so the first thing is we have a divide. So the first thing we ought to do really is we ought to factor as many of these polynomials as we can. Right, so let's do that. So this will become, let's have a look here, we need factors of 15 which will add up to 3. So let's look at 5p, you need to be good at this factoring. And we're going to need a 3. And they'll both be negative, so we end up with this. Make sure it's right, 5p squared minus 15 minus 1 is minus 16 plus 3. Okay, so we're dividing by. Right, so let's have a look here. We can have a 6p out the top here. And we'll have a 5p subtract 1. And down here we'll have a 2p squared. And we'll have a p plus 4. Like that. And this p squared plus p minus 12, we need factors of negative 12 add up to 1, so it's 4 and negative 3. And so we'd end up with this. Okay, so now since this is a divide, what we'd have is 5p subtract 1 by p subtract 3 over p plus 4 by p subtract 3. Now times by, we invert it, 2p squared by p plus 4 over 6p by 5p subtract 1. Alright, now what we can do here, of course, is p plus 4 is in both the top and the bottom now. P minus 3 is in both the top and the bottom. And 5p subtract 1 is both in the top and the bottom. So really what I have here is 2 by p is p squared over 2 by 3 by p. Alright, so the p's will cancel, the 2's will cancel, and we're left with p over 3 being the result. Alright, so that's how we do that one. Alright, part D. Okay, let's try one last one. So let's suppose I have a squared minus 1 over a cubed minus 1. And we're multiplying by ab minus 2b plus 3a minus 6 all over ab plus 3a, I should say, plus b plus 3. Okay, so notice that we're multiplying here. So this, first of all, we have the difference of two squares here. And in the bottom I have the difference of two cubes. Like so. Alright, so next, of course, we can use grouping in the top here. So I could take out a B and get an A minus 2. And we could take out a 3 here and get a minus 2. And in the bottom here I could take out an A and get a B plus 3 and plus AB plus 3, like there's a 1 in front. Right, so this becomes A subtract 1 by A plus 1 over A take 1 by A squared plus A plus 1. Right, now how does this tidy up? Well, I get an A minus 2 as a factor and a B plus 3 over. And the next one I get a B plus 3 and a plus 1. Right, now let's have a look and see. Well, we have an A minus 1 here and an A minus 1 here. We have an A plus 1 here and an A plus 1 here. We have a B plus 3 here and a B plus 3 here. And so this will leave me with A subtract 2 over A squared plus A plus 1 as my final result.